like actually learning and teaching. I felt like the last 3 weeks of last semester were just reviewing and studying, and I actually get to teach you again. Okay, so here we go. This should be a review. Go ahead and get out something to take notes on. The ratio of A to B is the quotient obtained by dividing A by B, where B cannot, does not, will not equal 0. So a ratio is a quotient. Quotient implies division. And of course, we are stipulating that B cannot equal 0 because y'all are welcome to use your microphones. Can't divide by 0. Right. It is illegal to divide by 0 in math. Divide by 0 equals BAM! Okay. So, there are 3 different ways that we can write a ratio. I do illegal math. Should make a t-shirt. I do illegal math. 3 ways to write a ratio. I bet you could come up with them. Oh. It's supposed to disappear as I click it. But I think we're having issues today. I will just write them. You can write a ratio as a fraction. You can write a ratio with a colon. Or you could write a ratio with the word 2 in between. All right? You read all of them, A to B, A to B, and A to B. You read them all in that manner, but there's 3 different ways to write it. Okay, so fraction, colon, and then 2. All right, now the fun stuff. Go ahead and simplify these. These are your first 3 examples, and we'll talk about it in a minute, and I'll call on people. Okay, let's focus on this first one first, number 1. My recommendation to you on ones like this is to take each variable, each type, one at a time. So do the numbers first, do the x's second, do the y's third, and do the z's fourth. Take them one at a time on their own. So if I were to ask you 2/12, what does that simplify to? Abbas, what would you say? What does 2/12 simplify to? Have to keep going, sorry. Okay, so it simplifies to 1/6. So I'm done with the 2/12, and I don't have to worry about it anymore. Oh, sorry, okay. The next part of this fraction is x, but there's no other x. It's just x, and there's nothing below it. And so we're going to keep x right where he was, right there. The next one is y. Do y'all remember what to do with the exponents when you're dividing? When you're multiplying, you add the exponents. When you're dividing, very good. You subtract the exponents. 6 minus 3 is 3. Now, where do I put y to the third? Where does it go? Good. It goes wherever the larger one came from. So if the larger number was in the numerator, then it goes in the numerator. And then this is technically z to the 1. It's not z to the 0, it's z to the 1. So 2 minus 1 is 1. And you put it where the larger one came from. The larger one came in the denominator, or was in the denominator. So technically our final answer, if we get rid of all the unnecessary stuff, is x times y cubed over 6z. Are we okay there? Now if you ever forget what to do with the exponents, like you forget your exponent rules, you could always do, I know this is ridiculous, but this is just if you forget. You could put 6 y's in the numerator, 3 y's in the denominator, and you could cross them out 1 by 1. And what are you left with? Oh, you're left with 3 y's in the numerator, and so that's why y to the third goes in the numerator. We haven't done number 2 yet, Edriel. Okay, let's do number 2. 10 yards to 15 feet. Now, we talked about how there's 3 yards in a foot. You cannot simplify a ratio where the units are different. The units have to be the same in order to simplify it. So we are ready to simplify number 2. Sorry about that, we got a little confused. So we need to adjust one of these. We can put all of it in yards or we can put all of it in feet. It doesn't matter. I'm going to put all of it in yards. I know that there are 3 feet in a yard. So instead of 15 feet, I'm going to divide it by 3. And so it is not 15 feet, it is 5 yards. And so now we're going to simplify it, and the yards are going to cancel. Yards divided by yards is just 1. So yards are going to cancel, and 10 to 5 is 2 to 1. Or just 2. But if we're going to write it as a ratio, we would write 2 to 1. Are we okay here? Next one. The ratio of teachers to students if there are 180 teachers and 2,440 students. It says teachers to students. So we want to put the teachers first and the students second, and then we always reduce. Ms. Tanton, do we have to reduce? Yes, you have to reduce. You always have to reduce. So don't ask me if you have to reduce, because you reduce every time, all the time, no matter what. So the calculator trick is you can go to your calculator. You can put 180 divided by 2,440, and then you can do math, enter, enter. And reduced, it is 9 to 122. Of course, if you want to find the largest number that divides into both of those numbers and do it by hand, that is awesome as well. Let's keep going. Oops. Come on. There you go. As usual, we're going to have to save the video for the end if we have time. All right, the next one. So we talked about ratios. Now we're going to talk about a proportion. A proportion is when you take 2 ratios and you put an equal sign between them. So a proportion is simply an equation that states that 2 ratios are equal. So that's the difference between a ratio and a proportion. A ratio is just a comparison of 2 numbers, whereas a proportion is a statement that 2 ratios are equal. So those are different. Get it straight in your head what a ratio is versus a proportion. All right. How do you determine if 2 ratios are proportional? How do you determine? You could simplify both of them. You could simplify what is 6 over 24, what does that reduce to? 4 over 16, what does that reduce to? Or you could cross multiply them, that works as well, by moving the balloon. Oh, you're funny. So 6 over 24 is really 1/4, and 4 over 16 is really 1/4. So do they form a proportion? Yes, they do. There's a delay there. That was awesome. Okay, what is 2 over 9 reduced to? Well, you can't reduce that one. 2/9 is 2/9. Same with 3/10. You cannot reduce it. And so, obviously, that would not form a proportion because they are not equal. So, when you get that they're equal, the answer is yes. And when you get that they're not equal, the answer is no. That's easy. Equal is yes, and not equal is no. All right, sometimes, of course, our proportions might have unknowns. They might have a variable. So when there is a variable, we're going to cross multiply to solve, and we have covered this already in this class. Okay, go ahead and work on those 2, please. Okay, Ariana says that for A, X is 8. Oops. And Dustin got 10 for part B. So we cross multiply, and you know the trick, you can just cross multiply and divide. You don't even necessarily have to write it out. 6 times 4 divided by 3. You can just do it that quickly, all in one step. Or you could say 24 equals 3x, and then you could divide by 3. That's up to you. Now, it's important on part B, very important, that you write the first number in the numerator and the second number in the denominator. So, instead of writing 3 is to 5 as 6 is to x, I would write it as a fraction. 3 is to 5 as 6 is to x, and then do your magical cross multiplying. 6 times 5 divided by 3. All right, try that one, please. So on this one, it's really important that you write it as a fraction first. 7 over 6x minus 4, and then 9 over 4x plus 6. You will definitely see this one on your test. So it is really important that you first write it as a fraction, please. And then you can do your cross multiplying. Yep. Uh-oh. How did that happen? Okay. Then you can cross multiply. You can look on the calendar. It's not for a while. Lars, do you have an answer? Make sure when you're cross multiplying that you distribute. Okay. Y'all okay with that so far? Cross multiply, distribute. Okay. And then we know solve for x. Add 36 to both sides, subtract 28x from both sides. Answer? Karthik, it was not your turn. Okay. Did we all get 3? Any questions? Yay, algebra. Oh man, one more. Then go get a calculator. No excuses. This one is really important also, that you use your binomial multiplication rules. Binomial multiplication rules. AKA make sure you FOIL, okay? 21 times x plus 2 is 21x plus 42, so that's really important. And then, when you go the other way, I would recommend you write it out first, because you're going to have to FOIL. No, it's not a trinomial, it's a binomial. So make sure that you FOIL these two. It's going to get uglier before it gets prettier. 21x plus 42 equals x squared plus 14x plus 48. The bad news is that we have an x squared, which probably means that we're going to have to factor, right? So if we bring everything over to this side, we've got x squared equals, oops, not x squared equals, sorry, 0 equals x squared minus 7x plus 6. Oh, that's nice. I need two things that multiply to get 6 and subtract to get 7. So I got x, negative 6, negative 1. So, yes, you had to FOIL. Yes, you got a quadratic. Yes, you had to factor. And yes, there are 2 answers. 2 answers, and they are 1 and 6. So go back and look at that again tonight if you had trouble with that one. There were a lot of steps to that one. That one was truly K-level. We're actually going to skip that one for today. We're going to move on to a couple word problems. A 168-inch flagpole is divided in a ratio of 2 to 3 to 7. What is the length of each part of the flagpole? Okay, Abby, I'll pick you. Have to move your card to the front. So you remember these ratio problems. They come up a lot and y'all seem to forget what to do sometimes, but it's really not that bad. Oh, thank you. It's really not that bad. Every time you see a ratio like that, you're literally just attaching an x to each one. So 2x plus 3x plus 7x equals 168. What do we have? 12x. So 168 divided by 12. And then you simply plug it back in. 14 times 2, 14 times 3, and 14 times 7. And do we have any units? Yep, inches. Inches, 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 comma, comma, circle. So remember when we have those, when we have a ratio, you attach an x to it. Are we okay with the answers I got? 28, 42, 98? Okay, good. You have to check me. I think this is one of the last ones. If about 4,850 fatal car crashes per year are caused by teen drivers and about 35,150 fatal car crashes are caused by drivers over the age of 20, what is the ratio of teen driver crashes to total crashes? These are real statistics. I think they're a couple of years old, but they are real statistics from a couple of years ago when I did this problem. Yeah, it is sad. So what do we need to do first? It says what's the ratio of teen to total? So it means that you're going to need to add them up because we don't have a total yet, do we? Yeah. Okay, Graham, tell me what you get for the reduced ratio when you get it. Graham, tell me what you get for the reduced ratio. Because we had a campaign a few years ago, Karthik, that said on the shirt like 40,000, 40,000. It was big numbers on our shirt, and it was like talking about awareness of teens in the driver's seat. Very good, Graham. 97 to 800. So remember, you just put those in your calculator, you divide them, and you do math, enter, enter. Okay? That is all we have for today.